Now let us keep in mind that as function is fundamentally a relation, the different types of relation, that is one, many one, onto, into, apply to functions also, right? Also the terms like domain, range, codomain, etc. are equally applicable to function. So this is because since function is a relation, so all the terminologies with respect to a relation are equally valid for a function also, right? Now let's move ahead and see the different ways of representing a function. These are nothing but the different notations and different conventions. The first one is what we call as f of x notation. Now to understand this, we can visualize any function as a kind of, say, black box or some kind of processing machine which accepts the input denoted by x and which sends out an output denoted as f of x. Sometimes we also denote this output as some variable, say y. So y is equal to f of x. Now what happens inside this box depends on how the function is defined. So suppose we define some function, say f of x, as x square. So it just means that whatever x we are sending in as the input, the output will be nothing but the square of that particular input. Alright. So this is what we call as the definition of the function in this example. Now we have to keep in mind that like a relation, this function will also have some domain, codomain and range. So here let us restrict the values of x to natural numbers and say x is less than or equal to 4. Now the values which are allowed for x to have in this particular example of function is the natural numbers less than or equal to 4. So that means x will take the values as 1, 2, 3 and 4. These are the only possible values for x, isn't it? Now if that is the case, then the corresponding values of f of x are nothing but the square of the value of x. So here we will get the squares of 1, 2, 3 and 4, which are 1, 4, 9 and 16 respectively. So this is how we understand the notation of a function, and therefore this notation is a very useful and very compact, which we will be using most of the times. This is also called as the definition of the function because this is the expression which gives us the value of f of x. Now moving ahead, the other way is to write the roster form of the function. Now here if we recollect, roster form we studied while describing a set, and if we realize that a function is nothing but a relation and a relation is nothing but a set of ordered pairs. So ultimately function is also a set only, and since a set can be written in roster form, therefore it means that function also can be written in the roster form. So if we consider the previous function which we took as an example, we can write that particular function as the set of ordered pairs, that is first pair was 1, 1, it's a square of 1. Second pair we will write as 2, 4, 2 square is 4. Then the third is 3, 9 and last is 4, 16. Alright. So therefore this is the roster form. Now if we see that the list of all the first elements, that is 1, 2, 3, 4 forms the domain as per the definition of the domain, and the list of all second elements, that is 1, 4, 9 and 16 forms the range of the function, right? Okay. Now moving on, we can have the tabular form, which is one and the same thing that we did earlier. Now here we write the different values of x and the corresponding value of f of x in a tabular form. So we just tabulate this information. So here we have x, f of x. X has the values 1, 2, 3, 4 and f of x will have the values 1, 4, 9 and 16, which is really not a different thing. Let's go ahead and see The next is set builder notation. Now which is very much close to the definition of the function itself. That is, here we can write the function that we have in example as f of x is a set of all such values of say a, where we can write a is equal to b square, such that b is a natural number and b is less than or equal to 4. So in a way we have just written the definition of the function in the set builder notation. Alright, so this is the set builder way. And lastly we have the arrow diagram, which is nothing but a graphical representation of the function. So in this, what do we do is we first draw the first set, then we draw the second set, right? Now in the first set the only allowed values are 1, 2, 3 and 4, and here now we are not mentioned, we have not given what is the codomain here. So let us assume that the codomain, that is the second set, is the set of natural numbers. Let's call the first set as say A, right? Now when I say the set of all natural numbers, it will include all the numbers as 1, 2, 3, 4, 5, 6 and so on. Somewhere there will be 9, then somewhere there will be 16 and so on, and all the numbers. In between we know that 1 is connected with 1, 2 is connected with 4, 3 with 9 and 4 with 16. Alright, so this is the arrow diagram, that is the pictorial representation of a set.